So the second paper in this session is challenging our thinking regarding elevator accidents. And this paper will be presented by Roger Kahler of Intersafe in Australia. So thank you, Roger, for being with us. And then it's my pleasure to introduce you to the audience. So Roger Kahler, since 1983, specialized in accident analysis, hazard studies, audits, implementation of occupational health and safety systems, strategic accident analysis, industry training, and advice to the legal profession. Roger has experience in the detailed investigation of over 5,000 accidents, and this was done for the legal profession, multinational, national companies. He has also led intensive training of industrial management, medical staff, and the workforce in many areas. So thank you, Roger, for being with us. And let me just pass the microphone to you.
Thank you. So thank you for the opportunity to speak. I'd like to speak to you as if I am a research scientist tonight, but I'm also a mechanical engineer and a human factors specialist. My association with the lift industry is just one of the many industries that I touch, but I have come to believe that there is opportunity for the lift industry to more strongly embrace the scientific process. And the scientific process is defined as involving the tools of modeling, taxonomy, and hypothesis forming and testing. Now, just a quick introduction to taxonomy, because I will use the word regularly. It's basically the oldest of the scientific sciences, and it's a classification system in which units of information have similar enough properties to be grouped together, and you begin to see the patterns, and you begin to see the relative importance of what is known as the taxons, or the groups within the taxonomy. So that's a little bit of a sense of it, and taxonomy is a highly underutilized tool generally in the world of personal damage. Next slide. So it's another story to tell you why the word damage is being used here other than injury. But if you could just bear with me, is that when we talk about damage to people, it can be usefully classified into these three categories. Class 1 damage is permanent damage to people. The people will not recover back to a fully functional state when they have experienced Class 1 damage. Class 2 damage is temporary, and it's what many industries would classify as a lost time injury. And Class 3 is minor or inconvenience, a splinter in the finger, dust in the eye, something such as that. Fortunately, the majority of the damage experienced by a lift manufacturer or a lift owner is minor or temporary. And we measure that Class 2 and Class 3 damage, hoping to avoid Class 1. But when the Class 1 damage happens, expectations are defeated significantly, often in the senior leadership of the business. So I just want to build on the Class 1 story. And if we go to the next slide, the notion of the Pareto Principle, I would trust is familiar to many of the listeners, but it's simply the 80-20 rule and the rule of the critical few. Basically, a little does the most. And the research in this country, in Australia, which has encompassed the cost to the community, to the employer, to the insurer, etc., it shows quite clearly that 80 to 90% of the cost of all work-related damage is associated with Class 1 damage. So of those three classes, class 1, 2, and 3, class 1 is the Pareto level of damage. If we then look at class 1 damage, it has the subcategories of multiple fatalities, single fatalities, and then the next level down is non-fatal but permanent damage. And the Pareto Principle applies again. And it will be the case within the lift and escalators that we will find that the majority of the cost by any measure, be it pain, suffering, impairment, money, it doesn't matter what the measure is, it will be my hypothesis for this industry that the greatest cost is associated with non-fatal but permanent damage to people. But for ethical, moral, legal reasons, we must manage the fatality outcomes. But this is the critical observation, is that for every industry that I have had to study, and I haven't had a chance to study these levels of damage in the lift industry, but for every level of damage, the taxonomies of multiple fatalities are quite different to the taxonomies of single fatalities, and they are quite different again to the taxonomies of non-fatal permanent damage. So that's an important observation, because if we are to more strongly apply the scientific method, beginning with the taxonomic process, we must start to build very robust taxonomies of the multiple fatality, the single fatality, and the non-fatal permanent damage story, because in that work, we will begin to get the insights that we need. I could demonstrate just very quickly to give you a sense of it. If I was dealing with an underground coal mine, for example, the multiple fatality story is fire, explosion, and inrush. If I deal with the single fatality story, I'll be dealing with vehicle to pedestrian and fall of rock under about 2 ton. If I deal with the non-fatal permanent damage story, I have to start managing the ride quality of the vehicles, the quality of the access to the vehicles, and the tasks that are basically overstressing the musculoskeletal system. So to manage class 1 damage effectively, I've got to understand the pattern or taxonomies of every level, gain my insights, and move forward from there. And I suggest that the same has to apply strongly to the lift industry. If I go to the next slide, the previous slides have just been intended to show why the lift industry must be driven by the desire or the vision to eliminate class 1 damage and all its subcategories of multiple fatality, single fatality, and non-fatal permanent. Modeling is simply a frame of reference to guide observation, to guide our thinking, and to guide problems analysis. If I go to taxonomy, I've explained that in terms of pattern analysis of units of information, which in our case is damage to people. And a hypothesis is simply a testable proposition. And these are not independent concepts. They are, in fact, interacting concepts. And the industry must identify various hypotheses, and then there will be individuals within the industry that will challenge those hypotheses. For example, I'll give you an example for me of something that must be challenged in the industry. If I take the application of the safety brake in a lift, we put out data on what we would like to see as maximum accelerations, for example, about 1G. But involved in achieving that acceleration is the phenomena of jerk or rate of change of acceleration. And there is a strong hypothesis at the industry that jerk is a measure of comfort. But from the work that I get involved in the motor vehicle industry, and particularly rear impacts and other industries, I would suggest that if we had available taxonomies of non-fatal permanent damage that exist for user groups, we would find a taxon or a group of people experiencing permanent damage directly associated with the phenomena of jerk associated with the application of the safety brakes. And that is because the energy to do the damage is actually coming from internal to the person and not external to the person. And that's the phenomena that's being observed in areas outside the lift industry. So I just give that to you as an example of hypothesis forming and testing. The next slide is, if I go to the medical profession, which has had a profound effect on the life expectancy of people in Western countries in the last 100 years, and it's not a statistical shift that life expectancies have gone from about 50 to 60 years of age to over 80, is that their model engages this notion of a host agent and an environment and a vector. And the vector is simply the connector or the carrier in their world. So the host can be you, the agent, and this is in the case of malaria, the agent can be a parasite. The environment is the environment in which you work and live, and the vector, the connector, is the mosquito. And that industry makes the business of studying all of those interactions of those elements you see on the left. Well, in my world, when I go to the world of ergonomics and engineering, I believe the model has to be looking something like we have people, equipment, and environment interacting, whether it is the lift maintainer, user, constructor, and our vector, the connector, is energy. Because the moment we build these facilities, we introduce energies of various types into the system. And so I think that we have to develop an appropriate model. And in my experience in dealing with people in this industry, is that if I sit and look at a model that sits adjacent to these medical and ergonomic engineering models, it's what I call the egocentric model. An ego being a person or centric being the center of. And it is so strongly that I observe that the desire is to focus on an appropriate person at the center of the incident. The child, for example, who may be on the top of a guardrail of an escalator, for example, is that, and in that egocentric model, we don't appreciate that as we start to think about our problem with the lift or the escalator in terms of unsafe acts and unsafe conditions, that we have applied a value judgment to our observation and we only write down our perception of unsafe, and we miss our opportunity because the solutions can lie in our very perceived view of what is safe. And so when you move to more strongly to medical or to ergonomic and engineering models, there is certain language that must disappear if we're going to make the next level of progress, because there has been a lot of progress made, but I believe the next decade will be harder. And if we're going to make the progress, then we have to challenge some very fundamental thinking. So if I just move to the next slide, this, for me, is an important model. In the medical world, we have what they call the pre-event, the event, and the post-event phases with respect to a disease. And they study every one of those time zones with the model that I showed previously. When we were doing a lot of work in the agricultural industry about 30 years ago, we found that we could take the event phase of an incident and break it into the time zones that you see here of stable, metastable, unstable, and damage. And you can see the words accompanying. Metastable, it's moving out of control but recoverable. Unstable, it's completely out of control, not recoverable. And then the damage occurs where there's an energy exchange takes place. And it's very important to, I believe, when you deal with lift incidents, to be able to be using a frame of reference like this to understand the interaction that is going on so that we can find opportunities for the future in each of these time zones, not just in the stable time zone. And to do that, our frame of reference has to change. Now, the lift industry already does some really excellent things, because if I just take lift doors equipped with their sensors, the door and its associated mechanism and technology acts as an information detector, an information processor, and a decision maker, and the person doesn't get knocked down by the door. In the same way, we have to think more strongly in terms of, let's take work within a lift shaft. We have to start thinking about the equipment in terms of a lift being a information detector, information processor, decision maker, to determine, to see if we have opportunities that we are missing with respect to those incidents that we are seeing in that aspect. So I think there is a challenge before us with respect to the language that we use, with respect to the models that we use, and the building of relevant taxonomies. The next slide, please. This is just, I took this from a document related to Hong Kong that's published in the public arena. But in this particular incident, you can see a person has been caught between the top of the lift car and the top of the landing level. And basically there was lift maintenance going on. The doors of the car were open. The doors of the landing level were open. And the car was lower down, but for one reason or another, it was activated and it starts traveling upwards and it picks up the person near the landing doors and then crushes them to death. I think for me, there are two lessons when I look at this, because when I looked at the published controls, and this is what you see so often, they are so strongly in the administrative space. They were all about the training, the procedures, and the competencies, etc., and what we must do to keep the situation in the stable time zone. But if we were looking at an incident like that with different models and a different frame of reference, then for me, the challenge is, can we find ways to take some component of the equipment or the environment as an information detector, information processor, decision maker, and that person not pay the ultimate price for simply making adjustments to the lift? So we have to slow down our thinking and challenge our thinking, I believe, if we are to make the next level of progress. The other one for me when I read this is, you so often read the same outcomes that are published when you read about lift fatalities, the training, the competency, let's do the compliance. And I think we have opportunities going forward to draw heavily on human social processes that we don't see in the health and safety space with respect to how we do sustain critical behaviors to keep things in the stable time zone. But when that surely fails us, then there have to be layers of control beyond that time zone. So if I go to the last slide, as I stand back and say to myself, what do I see as a way forward for this industry? It's not that there aren't a lot of people out there doing a lot of excellent work, continuing to push boundaries. But my struggle always has been, in my association with the lift industry, is to find very strong and very robust taxonomies for the different user groups, the installers, the maintainers, and the end users. And taxonomies are associated with class 1 damage because it is the Pareto level of damage. So we must strive to produce taxonomies of the multiple fatality story. We must strive to produce taxonomies of the single fatality story, and then the non-fatal but permanent story for those three user groups. And to complete that taxonomy, there would be a need to go globally and find about 2,000 units of information, particularly based on descriptive data. And then I believe we would have more focused conversations drawing clearly on the pattern of what is occurring. And my experience around the world, not in your industry, but in other industries, tells me that whether I am doing work in Mongolia, Central America, North America, or Australia, the moment we bring various energies into existence in particular equipment configurations, the patterns are similar. So that's why I believe we can draw upon global data in helping us develop these taxonomies in going forward. So That's it for me. Thank you very much for listening.